So children, today let us work the examples and some of the exercise problems of our chapter electricity. Right? Okay. So right, that's good. Right. We'll talk about some examples, and the and the exercise problems. Right. Okay. Right. So we now talk about the first example. Some of the examples we have already worked, and this example, follow carefully, children. So we're going to work this example now. So that is all right. That is the example, and you can see the example here on the screen, children. Right. So what is that problem telling? So this is saying that an electric lamp whose resistance is 20 ohm, that's 20 ohm, and a conductor 4 ohm. They are connected to the same source, that is a 6-volt battery. Now we have to calculate the total resistance, then next the current through the circuit, and the potential difference across the electric lamp and the conductor. Right. So let us go ahead, children. So now the first part will work. Given resistance of the bulb. Resistance of the bulb is 20 ohm. Resistance of the conductor is 4 ohm. So total resistance is equal to, as they are connected in series, total resistance will be 20 plus 4, that will be equal to 24 ohm. So that is the total resistance. Now what is the next thing that we have to find? So the total current that is passing through the circuit. So okay, right. So we have potential difference V equal to 6 volt, and the total resistance we have calculated, that is equal to 24 ohm. Okay, next one. We employ Ohm's law. We know well V is equal to IR. So I want the I value of I. So right, okay, so that is I. I is equal to V by R. So what will that be, children? So V equal to 6 by, that's 24, and that will be 6 ones, 6 fours, that is 1 by 4. Okay, that will be equal to 0.25 ampere. Okay, right. So what is the third thing that we have to find? So that is the potential difference across the electric lamp and the conductor. Follow carefully, children. So this source 6 volt, it exerts some potential difference here, and it also exerts some potential difference here. So that is, it uses some energy here, some energy here. Out of 6 volts, some here is some here, and we know here it is 20 omega or ohms. Now follow carefully. So right, okay. So for the conductor, so I'll write I'll find out the potential difference across the conductor. Right, conductor, and then next we have the bulb. Right, okay, that's good. The next one, what is the resistance of the conductor? So it's 4 ohm, and the current in the conductor, so that is 0.25 ampere. Now next one, what would be the potential difference? Employing the Ohm's law, V equal to IR. So I calculate I is 0.25 times 4, so that will be 1 volt. So the potential difference of the conductor across the conductor is 1 volt, and naturally the remaining potential difference would be for the bulb. So but still we'll calculate that, right? Okay, R equal to, how much is that, children? So that's 20 ohm, 20 ohm, and the next so we have I is the same current, 0.25 ampere, and there we are. So we'll calculate V equal to IR, the potential difference. What is I, children? So it is 0.25 into R is 20, so that will become 5 volts. So there we are, children. So that's, we have calculated it. We have calculated the requirement. Right. Okay, we go to the next problem now. So children, we'll work example 12.8. So there we are. There are 3 resistors connected in parallel to the source of a 12 volt. We have to calculate the current in each of the resistors. Then next we have to calculate the total current in the circuit, as well as the total circuit resistance. Then how do we do it? The first one. So right, let's calculate the current in each of the resistors. So the R1, and we have to R2, and that's R2. Let's write like that. And what is R1, children? So it gives us R1 is 5 ohm. Okay, right, I'll write 5 ohm. And the next this is 10 ohm. And that is 30 ohm. Right, okay. So, but what is the potential difference across each? So as they are all connected to the same source and they are all in parallel connection, each of them will have a potential difference of 12 volts. Okay, good, 12 volts. Very nice. The next one, right? So I had to calculate I. So I know that I is equal to we know is equal to IR. So that is Ohm's law, right? Okay, right. V is equal to IR is Ohm's law. Now what is I? I is equal to V by R, right? Good, right? So that is by Ohm's law, right? Okay, so there we are. We'll write I1 equal to V by R. Now that will become V is 12 by 5, and that's 5 2 is 10, 5 4 is 20. So that becomes I1 is equal to 2.4 ampere. Right, okay, next one now. So we have the next part, and we calculate the I2 here. So employ the same thing, V by R. So what is V, children, here? That's 12, sorry, by 10. That become equal to 1.2 ampere. I2 is equal to 1.2 ampere. So this was 2.4 ampere. Very fine. Now we are moving to the next one. So I3. Let us calculate the current in the resistance I3. Resistance 3. So it is V by R again. What is V, children? So it's 12 by 30. So that becomes 3 tenths. That is 3 fourths. That is 0.4 ampere. Right. So this is I3. So write it properly. That's I3. Right. Good. Now, what is the total current in the circuit? We know well, as the three resistors are connected in parallel. So the total current in the circuit will be equal to I1 plus I2 plus I3. Why? So, okay, right, if you want, you just can refer to the diagram. So this is I1, I2, I3, and all of them combine again here. So naturally, this current will be equal to I1 plus I2 plus I3, I1 plus I2 plus I3. So, okay, right, so just remove it again. All right, okay, there we are. Right, now we go to working with that solution, right? So, okay, right, there's I3. So it's 2.4 ampere plus 1.2 ampere plus 0.4 ampere. Now, how much would that be? So it's 2.4, then 1.2, and 0.4. That'll add up to 0, 1. That is 4. 4 is right, okay, 4 ampere. So total current is 4 ampere, right? Okay, also 4 ampere. Right, okay, that's it. Total current is 4 ampere. Now, what's the next thing? What's the next thing that we have to find? So, right, okay, we have found the current in each, right, and the total current in the circuit, and the total circuit resistance. So, naturally, as they are all connected in parallel, so we employ the parallel formula for the group of resistors connected in the parallel. So, what is that, children? So, what is that? Right, okay, so we have a total resistance is equal to total effective resistance RE is equal to what? So that is, as there's a parallel connection, total effective resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now what will this be? 1 by, how much is that, children? The first one? That is, okay, we'll see, that's 5, 10, and 30. Okay, so we go to 5, 10, and 30 down. 1 by 5 plus 1 by 10 plus 1 by 30. So now there's here, right, okay, 35, 6 plus 3 plus 1. So that will become 10 by 30. That will be equal to 1 by 3. Okay, good. So now, right, okay, so 1 by RE is equal to equivalent resistance 1 by 3. So our effective resistance is equal to 3 ohm. So children, that's it. So this is what is the second one, right? So children, right, now we'll work this problem, 12.9. 12.9, right? So what is that problem? There we are. We have problem number 12.9, right? Okay, now, so in this figure, you can find R1 is 10 ohm, so that is 10 ohm, and R2 is 40 ohm, that's 40 ohm, okay, good. R3 is 30 ohm, that's 30 ohm. The next one, this one is 20 ohm, and that is 60 ohm, good. Now, and they're all connected to one source, right? Okay, right. Now you tell the total resistance in the circuit. What is the total resistance in the circuit? And the total current flowing in the circuit, right? Okay, how do we do it? Now, okay, right, when I observe carefully, R1 and R2, R1 and R2, they are in parallel. They are in parallel, okay, right. And similarly, we have R3, R4, and R5. They are also in parallel connection, okay, good, right. So what would be the formula that we have to employ? So Rx, say, let us call that Rx, that resistance, the effective resistance due to both of them. So that is 10 ohm and 40 ohm. So we know well that R1, R2 by R1 plus R2, we have employed the same formula of parallel, but we have done that LCM and all. Okay, right. So it becomes, what is the R1, children? That is 10 and 40, right? Okay. 10 times 40 divided by 10 plus 40. So that will become 400 divided by 50. So 80. So 80 ohm. Sorry, that is 8 ohm. I'm very sorry. That is 8 ohm. Okay. So we got 8 ohm, Rx. Now let us calculate this Ry. So 30, 20, and 60. So this is also a parallel connection. So let me call it as Ry. So that will be 1 by 30 plus 1 by 20 plus 1 by 60. Okay, right. Take the LCM, that's 60. 2's plus 3 plus 1. So it becomes 6 by 60. Right? 6 by 60. How much will that be? So that will be equal to 1 by 10. That is the 1 by 10, right? Okay, good. That's 1 by 10. So that's 1 by Ry equal to 1 by 10. So Ry should be equal to 10. Now, what has he asked? He has asked what is the total resistance in the circuit. So now this part and this, both of them will be in series, right? Okay. So what will happen? So what did we get? So what is that? Okay. So total, as for the first part, total resistance in the circuit, right, that will be equal to Rx plus Ry. That is 8 ohm plus 10 ohm. That will be 18 ohm. Okay, good. Now we are moving to the next one. So what should we do? Right, if there is a resistance, the total current in the circuit. Now, what is the total current in the circuit? So the total current. So we know R equal to 18 ohm. That is the total resistance. And V is equal to, what is V? So that is 12 volts. Okay, good. 12 volts. That is 12 volts. Now, what is current? So, okay, from this, I use Ohm's law. So we know well that is V equal to IR. I want current I equal to V by R. So that's what I employ here. Okay, right. So from this I write I equal to V by R. So what is V, children? It's 12 by R is 18. 6 to 12, that's 3. That is 0.667 is the ampere, right? Okay, that many ampere. So that is the third problem. So children, right, that's it.